Hi folks, this is Karim Raouf from our IT Visualizer channel. We will continue our lab, the Matrix Labs, the video number 29. We've been discussing in the previous video the following. We have been working on introducing the rep admin tool, which is a very important tool to discover the Active Directory replication problems. We have discussed the terminologies that are associated with the rep admin tool. So for example, what is replication, what is pull replication, what is inter-site replication, what is intra-site replication, a lot of terminologies that are used when using this tool. And we will have discussed that the replication is not only the replication of the Active Directory database, but other components are replicated as well, and they are very, very important. It's something like replication state, not only copying files. This is what Mr. Loeb van der Poel is saying in his slides. So we are replicating the Active Directory database, the DNS zones related to the domain controllers. We all know that when we promote a server to be a domain controller, we will see that automatically DNS servers are created on this domain controller and they are integrated with the Active Directory. Okay, so for example, if you join a computer to the domain, it will be automatically or a record for it will be created in the DNS, which is already installed when you promote the server to be a domain controller, and it is very, very related and very, very close to the Active Directory. So when we replicate the Active Directory database, the DNS zones related to the domain controller or to the domain, and we also replicate the global catalogs, which are very, very important concept or a feature that is installed on the domain controller, which is something like a snapshot from all of the objects in the forest. So if any domain have this feature is asked about any object in the forest, for example, a user, a group, or a computer, he will have the answer and the location, or it will redirect the requester to the location of the object he seeks. So now we will continue working on some terminologies, or we will focus on the replication process. So if we go to our slides, we will see this is a scenario. We have the parent domain and we have three subdomains: domain B, domain C, and domain D, and this is a forest. So we can see here that the replication, we have the Active Directory database, the schema, the configuration, the domain partition, and application, which is not included here because we don't have any applications installed that depend on the Active Directory. And then we have the DNS, domain DNS zone, the forest DNS zone, and the global catalog. Okay, some of these partitions, the Active Directory, are replicated through the whole forest. We have said this before, the schema and the configuration partition, and some are replicated within the same domain, which is the domain partition. It is replicated between Active Directory databases within the same site. Okay, this is one thing. Okay, and as we can see here, for example, the domain DNS also, it is replicated within the same site. Okay, so the domain DNS zone and the domain partition, they are replicated to Active Directory databases within the same site or within the same domain or subdomain. Okay, as for the forest DNS zones and the global catalog, these are features that are replicated within the whole forest. So this is the forest DNS zone. If you need to locate any domain controller within the forest, okay, this will be used. If you need to locate a certain object within the forest, this will be this will be asked. So these two should be the same on all of the domain controllers in the whole forest. Okay, so as we see, very, very simple diagram, we need to ask the AI tools to explain how this is done and to give us an explanation first, and then we have an example. So let's see what ChatGPT 4o will say about it. If we go there and ask it to explain this using a real world example, here is the answer.
Let's explain the diagram using a real-world example with Matrix Corp and their domain named matrix.internal. Real-world example, Matrix Corp's Active Directory structure. Matrix Corp has several offices, and they are organized into different domains within their Active Directory forest. Let's say these domains are Domain A, headquarters in Cairo, Domain B, branch office in Alexandria, Domain C, branch office in Giza. Explanation of the diagram. 1. Active Directory Forest. The top part of the diagram shows an Active Directory forest, which includes multiple domains A and C. The forest represents the entire network for Matrix Corp, encompassing all their offices. 2. Domains. Each domain A, B, and C represents a different office location within Matrix Corp. Inside each domain, you see several layers, which are different parts of the Active Directory database. Components of each domain. 1. Schema. Example. The schema is like the rulebook for Matrix Corp's network. It defines what types of information, attributes, can be stored about users, computers, and other resources. All domains A, B, C share the same schema to ensure consistency in how information is stored. 2. Configuration. Example. Configuration contains settings and information about the overall structure of Matrix Corp's Active Directory, like what domains exist and how they are connected. This information is also shared among all domains to keep the network configuration consistent. 3. Domain-specific data. Example, each domain has specific data unique to that office. For instance, Domain A, Cairo, has information about Cairo employees, computers, and resources, while Domain B, Alexandria, has its own local data. This is represented by the pink domain layer in the diagram. 4. DNS zones. Example, domain DNS zones contain information to help computers find each other, using names instead of IP addresses. For instance, email.matrix.internal resolves to the email server's IP address. Each domain has its own DNS zones, but also shares some information across the entire network. 5. Global catalog. Example, the global catalog is like a quick reference guide that contains important information from all domains. If someone in Cairo needs to find a resource in Alexandria, the global catalog helps quickly locate it. This ensures that all domains can access necessary information across the entire network. Replication and synchronization. The arrows between the domains show the replication connections. These connections are how changes made in one domain are shared with the others. For example, if a new user is added in domain A, Cairo, this information is replicated to domain B, Alexandria, and domain C, Giza. This ensures that all offices have the latest information. Disconnected operation. If the connection between Cairo and Alexandria goes down temporarily, each domain can continue to operate and accept changes locally. Once the connection is restored, all changes will be synchronized. Summary. Matrix Corp's Active Directory setup ensures that all their offices' domains are connected and share important information like user accounts, configurations, and DNS data. This setup helps keep everything consistent and up to date across the entire network, making sure that employees can access the resources they need no matter which office they are in. The diagram illustrates how different parts of the network are connected and how they replicate information to maintain synchronization.
So this is a good example. If you go and ask Claude to explain the same diagram using also real-world example, let's see if Claude 3.5 will explain it better than ChatGPT 4o. If you go further and ask it to explain it like that, let's go here and then tell it to read it loudly.
Ensuring seamless communication and consistency across the entire.
Okay, let's stop here and then let's go from the start, or let's go there.
repadmin.exe. Troubleshooting Active Directory replication. Certainly. Let's use the Matrix Corporation with the domain matrix internal to explain this diagram. Active Directory Forest. Imagine Matrix Corporation, matrix.internal, as a large organization with several divisions. In this example, we have Domain A, matrix.internal, parent domain. Domain B, hrmatrix.internal, human resources. Domain C, tech.matrix.internal, technology division. Domain D, finance.matrix.internal, finance department. These domains together form the Matrix Corporation's Active Directory forest. Domain structure. Each domain, matrix.internal, hrmatrix.internal, tech.matrix.internal, finance.matrix.internal has its own set of servers called domain controllers. These servers contain several layers of information. A schema. This is like the blueprint for all information in Matrix. For example, it defines what attributes an employee account should have: name, email, department, etc. B. Configuration. This contains information about how the Matrix network is set up, such as which offices, sites exist, and how they're connected. C. Domain. This is specific information for each division. For example, hrmatrix.internal would contain all employee accounts and their details. D. Domain DNS zones. This helps computers in Matrix find each other. For instance, it would help locate printer01.tech.matrix.internal. E. Forest DNS zones. This contains DNS information shared across all Matrix divisions. F. GC. Global Catalog. This is a quick reference guide containing the most important information from all Matrix divisions. Replication. The arrows between domains show how information is shared. Schema and configuration are replicated across all domains. So if Matrix adds a new attribute for cybersecurity clearance, it's added to all domains. Domain-specific information, like employee accounts, is primarily kept within each domain, but some key information is shared via the global catalog. DNS information is shared as needed to ensure all parts of Matrix can communicate effectively. In practice, this means an IT admin in tech.matrix internal can make a network-wide change that affects all of Matrix. An HR manager in HR Matrix internal can update an employee's information, and it's immediately available within HR, while key details become available company-wide through the global catalog. When finance.matrix internal adds a new server, other divisions can find and communicate with it thanks to the shared DNS information. This structure allows Matrix Corporation to maintain division-specific information while ensuring seamless communication and consistency across the entire organization.
Well, it is the same. This explanation is the same as ChatGPT for all, but I think they are equal here in this explanation, the two AI tool answer. Let's see here also another diagram. Here we can see this is like a screenshot for the replication model. Okay, so here we will see there is a couple of things. Here we have the terminology multi-master, which means that every domain controller can replicate and receive replication from the other domain controllers. No one is in a specific can replicate the changes, or a central server that will replicate the changes. All can receive and receive updates and send updates. Efficient transfer of data. This is using the KCC, so we will use the KCC to determine which servers are near to each other and the link between them is fast or slow, so we can begin the replication. Okay, and this will save time. Reliable consistency. All of the data, when replicated to the domain controllers or the Active Directory databases within the domain controllers, we have consistent data. The data will be the same on all of the domain controllers Active Directory databases. Conflict resolution. If two domain controllers are trying to change an object within the same time, there is some methods that can resolve this issue and help us to have one data with consistent or to have one data only changed. Okay, we will see something called timestamp. So if two servers are trying to change an object within the same time, the timestamp will be verified. The conflict resolution, or there is a number through which we can determine which server began changing the object first. Okay, anyway, so this is the AD replication model. We will see, or this is the characteristics of the replication within every Active Directory, or the replication model of the Active Directory. These are the characteristics. We have multi-master disease, we have efficient transfer of data, we have reliable consistency, we have conflict resolution. We will see how ChatGPT 4o will explain these characteristics. Let's go and ask it to give us the answer and give us a real-world example.
Let's use a real-world example of Matrix Corp with the domain named matrix.internal to explain the diagram and concepts in layman's terms. Real-world example, Matrix Corp's Active Directory replication topology. Matrix Corp has multiple offices, and they are organized into different domains within their Active Directory forest. Let's say these domains are Domain A, headquarters in Cairo, Domain B, branch office in Alexandria. Each domain has multiple domain controllers, DCs, which are servers responsible for managing the network resources. Explanation of the diagram. 1. Multi-master DCs. Definition. Every domain controller can receive updates and share them with others, rather than having a single primary server that handles all changes. Example. In Domain A Cairo, both A1 and A2 can receive updates, like adding a new user or changing a password. These updates are then shared with other DCs in the domain and across domains. 2. Efficient transfer of data. Definition. The system is designed to transfer updates quickly and efficiently. Example. When a change is made on DC A1 in Cairo, it is quickly shared with DC A2 in Cairo and then with DCs in Alexandria, B1, B2, to ensure everyone has the latest information. 3. Reliable consistency. Definition. The system ensures that all domain controllers have the same up-to-date information. Example. If a user changes their password on DC A2 in Cairo, this change is replicated to all other DCs in both Cairo and Alexandria, ensuring the user can log in with their new password at any office. 4. Conflict resolution. Definition. The system can handle situations where changes might conflict and ensures the correct information is used. Example. If a user's phone number is updated on DC-A1 in Cairo and also on DC-B1 in Alexandria at the same time, the system resolves this conflict and ensures the correct phone number is synchronized across all DCs. Key components in the diagram. 1. Domain A topology. Pink arrows. These arrows represent the connections within Domain A, Cairo, showing how DCs A1, A2, A3, and A4 are connected and share updates. 2. Domain B topology. These arrows represent the connections within Domain B, Alexandria, showing how DCs B1 and B2 are connected and share updates. 3. Schema configuration. Blue arrows. These arrows indicate the connections used to share the overall network configuration and rules schema between Domain A and Domain B, ensuring consistency across the entire network. Summary. In Matrix Corp, Active Directory replication ensures that all servers in different offices, domains, are synchronized efficiently and reliably. Each server, domain controller, can receive updates and share them with others, ensuring all information is up to date. The system handles potential conflicts to ensure data consistency, and it uses a well-designed topology to manage connections and data transfer between servers. By using this replication model, Matrix Corp ensures that all employees can access accurate and up-to-date information, no matter which office they are in, providing a smooth and efficient network experience.
So as we can see here, these are a good example to explain the AD replication model. Let's see if Claude can explain the same but in more convenient answer.
Certainly. Let's use the matrix corporation with the domain matrix internal to explain this diagram and concept. Replication topology. Imagine matrix corporation, matrix.internal, has several office locations, each with its own server. In this diagram, A1, A2, A3, and A4 represent servers in the main domain, matrix.internal. B1 represents a server in a subdomain, e.g., HR matrix.internal. AD replication model, A, multimaster DCs. Each server, A1, A2, A3, A4, B1, is a domain controller, DC, that can make and receive changes. For example, if an employee updates their phone number on A1, that change can be made directly without going through a central server. B. Efficient transfer of data. The arrows show how data is shared. For instance, when A1 updates employee information, it doesn't need to tell every other server directly. It might share with A2, which then shares with A4, ensuring efficient data transfer across the network. C. Reliable consistency. Despite having multiple servers that can make changes, the system ensures that all servers eventually have the same information. If an employee's title is updated in New York, A1, and their phone number is updated in Los Angeles, A3, both changes will be reflected across all servers. D. Conflict resolution. If conflicting changes occur, e.g., someone's title is updated differently on A1 and A3 at the same time, the system has ways to resolve this, usually by accepting the most recent change. Different topology types. Black arrows show how data specific to Matrix internal, like employee accounts, is shared among main domain servers. Green dotted arrows represent how data from the HR subdomain, hrmatrix.internal, is shared. Notice it doesn't connect directly to all servers. Pink arrows show how fundamental structure information, schema/configuration, is shared among all servers, including the subdomain. In practice for Matrix Corporation, when a new employee joins and their account is created on A1 in New York, this information is efficiently shared with other offices. If HR updates a company-wide policy on B1, it's shared across the entire network. If the IT team changes how user accounts are structured, schema change, this fundamental change is quickly propagated to all servers. Despite having servers in different locations, Matrix ensures that critical information is consistent across its entire network, while also maintaining efficient data transfer and the ability to resolve any conflicts that might arise from simultaneous updates. This system allows Matrix Corporation to maintain a reliable, efficient, and consistent network across all its offices, ensuring that whether an employee logs in from New York, Los Angeles, or any other location, they have access to up-to-date and accurate information.
So as we can see here, this example is good, but anyway, I think ChatGPT for all answer is better. Let's go and continue working with our tool ChatGPT for all. Here, can you compare between DC Diag tool and rep admin? Anyway, this is a general comparison between DC Diag tool tests in general with rep admin. I need only to focus on the the DC Diag tool replication test with the rep admin. Okay, so because this is the only DC Diag test that is concerned with the replication. So I need here to compare between a DC Diag tool replication test output and that for rep admin. If we go and ask it to give us a comparison, let's see the comparison between these two tools, and actually have simulated the output of both tools. Let's see the answer and see what is the comparison and small summary at the end. So let's ask ChatGPT to give us the answer.
Certainly. Let's compare the outputs of the DC Diag tool when running the replications test and the repadmin tool. Here's a detailed comparison of what each tool provides, focusing specifically on their replication-related outputs. DC Diag/test replications. Output, purpose. The DC Diag tool's replications test checks the replication status of domain controllers and reports any issues. Typical output, summary of replication status, provides a summary of the replication health for the domain controller being tested. Replication errors. Lists any replication errors found during the test. Replication partner information. Shows the status of replication with each replication partner. Last successful replication. Indicates the time of the last successful replication for each partner. Failure details. If there are any replication failures, it provides details about the errors and possible causes. Example output. Directory server diagnosis. Performing initial setup, connecting to directory service on server DC1, identified AD Forest, verifying replication health, testing server, site DC1, starting test, replications, replication latency check, DC equals example, DC equals com. Latency information for 5 entries in the vector were checked. 0 were delayed more than 24 hours. 0 were delayed more than a week. Replication partner check, CN equals schema, CN equals configuration equals example, DC equals com. Source DC2 status successful, Last attempt at 2024-623.12 was successful. C equals configuration, DC equals example, DC equals com. Source DC2 status successful. Last attempt at 2024-623.12 was successful. There are no replication errors. Test passed successfully. Output purpose. The repadmin tool provides detailed information and control over Active Directory replication processes, including current status and error details. Typical commands and outputs. One repadmin show REPL shows the replication status for the specified domain controller, detailing inbound and outbound replication partners and status. Example output. Default first site name, DC1 DSA options. ISGC site options. None. DSA object good 1234455 CDEF 56789 book def. DSA invocation ID 123456789 def. Topic inbound neighbors. C equals configuration, DC equals example, DC equals com. Default first site name, DC2 via RPC. DSA object GID 2345678 or ABCDF1 234567881. Last attempt at 2024-0623 LED was successful. Last success at 2024-62011 5 CN equals a schema, CN equals configuration, DC equals example, DC equals com. Default first site name, DC2 via RPC DSA object GID 2345678 or ABCDF1 234567881. Last attempt at 2024-0623 was successful. Last success at 2024-0623 Copic outbound neighbors. CN equals configuration, DC equals example, DC equals com. Default first site name, DC2 via RPC DSA object GUID 2345678 0ABC-def1 2345678 BZ-def1. Last attempt at 2024-0623 was successful. Last success at 2021 errors. 2. Repadmin/REPL summary provides a summary of the replication status across all domain controllers, including the number of successful replications and errors. Example output. Replication summary start time 2024-0623-12 Beginning data collection for replication summary. This may take a while. Source DSA, DC1 destination, DC2. Sync all report for DC's example, DC was common, site default, first site name, source, default first site name, DC1, destination, default first site name, DC2. Number of consecutive failures, 0. Number of consecutive successes, 1. Source, default first site name, DC1, destination, default first site name, DC2. Last attempt at 2024-0623 FIFA was successful. Number of successes, number of failures, 0. Replication summary. End time, 2024-0623 12 compare summary. Feature, DC diag, test replications, repadmin. Tool, keep comparison summary, primary function. Check the replication status as part of a broader domain controller health check. Detailed replication status and management. Output details, provides a summary and basic details of replication status, provides comprehensive details on replication status, including inbound and outbound neighbors. Error reporting, reports replication errors and potential causes, detailed error reports with replication attempts and successes failures. Replication partner info, lists replication partners and their status, detailed information on each replication partner, including GUIDs and timestamps. DC diag/test replications, repadmin show REPL, repadmin REPL summary. Use case, general health check for domain controllers, troubleshooting and managing specific replication issues. Summary, DC diag test replications provides a high-level overview of replication status as part of a broader health check. Useful for regular checks to ensure overall domain controller health. Repadmin offers detailed and specific information about replication status and issues. Essential for diagnosing and resolving detailed replication problems. Both tools are valuable for maintaining Active Directory health with DC diag, providing a broader health check, and repadmin offering in-depth replication management.
So this is a good answer, okay. So we know that we have two tools now, DC diag tool and repadmin tool. to diagnose problems concerning the domain controller and the replication of the Active Directory database. One tool also can be valuable if you need to monitor the replication between the domain controllers within the same site or between different sites. You can use the performance monitor tool, okay, and a couple of counters, okay. These counters will help you know the flow or how much data is going from your domain controller or going to your domain controller and out of your domain controller. So this is directory replication agent, okay, inbound bytes total per second. So there is a couple of counters you can add to the performance monitor to check the replication status. This is live monitoring, okay. Rep admin and dcdiag, I think it's they are like snapshots, or they are tests, and they are solving, or they are focusing on an instant or instantly, okay, or in a specific time. But this performance monitor, it is live monitoring. So let's see and discuss the different counters we can add to the performance monitor to check the status of the replication within the same site or between different sites. Let's see the answer of ChatGPT for all concerning this screenshot and the different counters added to it.
Let's explain the screenshot from Performance Monitor, taking into consideration the provided information about specific counters. The screenshot appears to show various Directory Replication Agent, DRA, counters related to Active Directory Replication activity. Explanation of the screenshot. The screenshot shows the Performance Monitor tool with a graph and a list of performance counters. These counters provide real-time data on various aspects of Active Directory replication.
So it failed to play the file. Okay, so let's wait for a moment.
Let's explain the screenshot from Performance Monitor, taking into consideration the provided information about specific counters. The screenshot appears to show various Directory Replication Agent, DRA, counters related to Active Directory replication activity. Explanation of the screenshot. The screenshot shows the Performance Monitor tool with a graph and a list of performance counters. These counters provide real-time data on various aspects of Active Directory replication. Highlighted counters. DRA inbound bytes total/SEC. Description. This counter shows the total number of bytes received per second for replication. Use. Helps understand the volume of data being replicated into the domain controller. If this value spikes, it indicates increased inbound replication activity. DRA inbound bytes not compressed within site/SEC. Description. Shows the number of inbound bytes per second that are not compressed and are replicated within the same site. Use. Helps identify the amount of data being replicated within the site without compression. DRA inbound bytes compressed between sites after compression/SEC. Description. Shows the number of inbound bytes per second that are compressed and replicated between different sites, measured after compression. Use. Indicates the efficiency of inter-site replication when data compression is used.
DRA outbound byte total sec.
Description. This counter shows the total number of bytes sent per second for replication. Use. Helps understand the volume of data being replicated out from the domain controller. Spikes in this value indicate increased outbound replication activity. DRA outbound bytes not compressed within site/SEC. Description. Shows the number of outbound bytes per second that are not compressed and are replicated within the same site. Use. Identifies the amount of data being replicated within the site without compression. DRA outbound bytes compressed between sites before compression/SEC. Description. Shows the number of outbound bytes per second that are compressed and replicated between different sites, measured before compression. Use indicates the volume of data being prepared for inter-site replication before compression. DRA outbound bytes compressed between sites after compression /SEC. Description shows the number of outbound bytes per second that are compressed and replicated between different sites, measured after compression. Use indicates the efficiency and volume of inter-site replication using compression. Other important counters, not shown in the screenshot but mentioned in the information provided. DS directory writes /SEC and DS directory reads /SEC. Description: these counters show the number of directory writes and reads per second. Use: they provide an indication of overall directory activity, including replication. Spikes may indicate changes being written to the directory, such as recalculating replication topology. LSAS private bytes. Description shows the amount of memory used by the Local Security Authority Subsystem Service, LSAS. Use: large or rapidly increasing values could indicate issues with the directory service, such as memory leaks or excessive load. NTDS threads in use. Description shows the number of threads currently in use by the NTDS Active Directory process. Use: an increase in this counter can indicate increased Active Directory activity, such as more replication operations or directory queries. Summary: the screenshot primarily focuses on replication-related counters for Active Directory, providing insights into the volume and efficiency of data being replicated both within and between sites. Understanding these counters can help diagnose and monitor the health and performance of Active Directory replication. For a comprehensive analysis, it would also be useful to monitor the additional counters mentioned: DS directory writes/reads, LSAS private bytes, and NTDS threads in use, to get a complete picture of Active Directory's performance and potential issues.
So this is a good answer. As we can see, these are all counters that will help us to monitor the Active Directory replication process. And think here I'm asking it to give us an example to explain on it. Okay, I think this is a very good example. Let's ask ChatGPT to explain it. So this is a real-world example to explain these counters. So this he's explaining the counters in theoretical, or the theoretical meaning or the definition of the counters, but we need to have an example to apply these counters to. So let's see the example provided by ChatGPT for all.
Sure. Let's explain everything in simple layman's terms using an example scenario. Scenario: Matrix Corp has multiple offices and uses a system called Active Directory AD to manage user accounts, computers, and other resources across these offices. They want to ensure that all offices have the same updated information. To do this, they use a process called replication to share updates between servers. Performance monitoring tools. Matrix Corp's IT team uses a tool called Performance Monitor to keep an eye on how well the replication process is working. Here's what they look at. Counters in the screenshot. 1. DRA inbound bytes total sec. What it means. This shows how much data in bytes is coming into the server every second from other servers for replication. Example: if Cairo's server receives a lot of data from Alexandria's server, this number will go up. 2. DRA inbound bytes not compressed within sec. What it means. This shows how much data is being received within the same office site without being compressed. Example: if servers within Cairo are sharing data that isn't compressed, this number reflects how much data that is. 3. DRA inbound bytes compressed between sites after compression. This shows how much data is received from other offices' sites after it has been compressed. Example: when data is sent from Alexandria to Cairo, it's compressed to save space. This number shows how much compressed data Cairo's server receives. 4. DRA outbound bytes total sec. What it means. This shows how much data is being sent out from the server every second to other servers for replication. Example: If Cairo's server is sending updates to Alexandria, this number shows how much data is being sent. 5. DRA outbound bytes not compressed. Within site, what it means. This shows how much data is being sent within the same office site without being compressed. Example, if Cairo's server sends data to another server in Cairo without compressing it, this number reflects that. 6. DRA outbound bytes compressed between sites before compression. This shows how much data is being sent to other offices before it gets compressed. Example, before Cairo's server sends data to Alexandria, it shows how much data is prepared to be sent before compression. 7. DRA outbound bytes compressed between sites after compression, sec. What it means. This shows how much data is being sent to other offices after it has been compressed. Example, this reflects the actual amount of compressed data being sent from Cairo to Alexandria. Additional important counters, not shown in the screenshot but important. 1. DS directory writes sec and DS directory reads sec. What it means. These show how often data is being written to and read from the directory. Example, when someone updates their password, the server writes this change. When someone logs in, the server reads their details. 2. LSAS private bytes. What it means. This shows how much memory the security service, LSAS, is using. Example, if this number gets very high, it might mean there's a problem, like the system is using too much memory and could slow down or crash. 3. NTDS threads in use. What it means. This shows how many processes threads the AD service is currently using. Example, if a lot of people are logging in or if there's a lot of replication happening, this number might go up, indicating the server is working hard. Why it matters. Understanding activity. These counters help the IT team understand how much data is being transferred and processed, ensuring all offices have up-to-date information. Identifying problems. If there are spikes or unusually high numbers, it might indicate a problem, such as too much data being sent/received, or the system using too much memory. Efficient management. By monitoring these values, the IT team can manage resources better and ensure that the Active Directory service is running smoothly. Summary. Matrix Corp's IT team uses these counters in Performance Monitor to keep track of how data is replicated between their servers in different offices. This helps them ensure that all updates are shared correctly and efficiently, and to spot and fix any issues that might arise in the replication process.
So as you can see here, very good example on how these counters is used to monitor a real-world scenario of an Active Directory. So we can see here that these are all good examples. Let's continue with the lab scenario, or let's continue with Mr. Lo van der Pol video. So as we can see here, one thing here Mr. Lo van der Pol is focusing on, for the Active Directory replication to happen, the Active Directory should translate your physical topology. So as we can see here, we have different sites with different links to these sites. These should all be translated to the Active Directory. Okay, it should know this physical structure, or it should be translated to a simple logical structure that the Active Directory can deal with, and it can know which sites are near, which sites are far, what are the links, the fast links to different sites, and what are the slow links. So Active Directory replication, Active Directory must understand your physical structure or network structure, your subnets, the IP for each site, where your domain controllers are located, okay, your WAN connections, okay, slow or fast, and if it is assigned a high metric or a high value, this means that this connection is fast. So for example, if we have two connections, one with value 10 and the other with value 11, then the link with value 11 means that the connection is fast. So this structure, or this physical structure, should be translated to the Active Directory. How this will be translated, let me show you also. For example, if you go to Mr. Lo van der Pol slides, here you go, this is the physical structure of your network or your domain. It will be translated to the Active Directory through the Active Directory sites and services. Here we can see that it is translated like a tree. Okay, first of all, this is the subnet of your site. We have only one site, HQ Home Lab. So if you have different sites, you will see every site, its subnet and the servers under it. So we can see here, this is the subnet of our site, which is HQ Home Lab, and these are the domain controllers within this site, and every domain controller have NTDS setting which will control to whom he will replicate, when the replication schedule will be done, and the cost or the links to the other sites. If this domain controller is replicating to other domain controllers in different sites, we will see the cost link, okay, for this site to the other sites. Okay, so the NTDS setting is very, very important. It will contain the data related to the replication process. Okay, all of these are translated from this physical structure to this logical structure that the Active Directory can comprehend and can deal with. Okay, so now the Active Directory can know that, for example, you have only one site, and these are the domain controllers, these are the replication setting, this is the IP or the subnet for your sites. So these are all translated in this logical structure. All of this data is saved to the configuration partition. So all of this data, okay, will be saved to the configuration partition, and it will be replicated to all of the domain controllers in the forest, and it should be the same. If this is not replicated correctly, you will find replication issues between your domain controllers. This is the topology, okay, of the network saved in the configuration partition. The sites, the domain controllers in the sites, the links between the sites, the replication schedule, the replication timing, or the replication, a lot of things actually, even the link or the site links, okay, or the WAN links cost is saved to the configuration partition. So this is very, very important thing to know. We need to make sure that this partition is replicated correctly to all of the Active Directory databases within the forest. So as we can see here, Mr. Love and Paul have 3 domain controllers. In his scenario, we have only 2. So we will work with our scenario, and we will see how this will be translated. And again, we can see this is different sites with different links, and we can see this is the rep admin. This is the rep admin tool, and then we will now see a couple of PowerShell commands. So we know that the rep admin, it is a command that it is not a PowerShell command, but it can be used within a PowerShell window, or a PowerShell prompt, or a PowerShell session, and it also can be used within a command prompt or a Windows command prompt session. Okay, so we will see a couple of these commands that will be useful to troubleshoot replication issues. So you can use the rep admin to troubleshoot replication issues. You can use this diag tool, test replications, to test replication issues, and you can use this couple of PowerShell commands. But before that, let me go to Mr. Love and Paul video and continue working with it. So as you can see here, this all slides, we have already seen these slides. Okay, and we have discussed all of these. So now we go and see a couple of commands. For example, get replication failure. This will get the replication failures on a domain controller. We will see a couple of these commands. We have asked, or I have asked one of the tools or AI tools, which is Perplexity, to ask it to give me a couple of PowerShell commands to troubleshoot Active Directory replication. Let's see the answer of Perplexity.
Here is a comprehensive response to the query about PowerShell commands related to Active Directory replication. Active Directory Replication PowerShell commands. Active Directory replication is a crucial process that ensures data consistency across all domain controllers in an Active Directory environment. PowerShell provides several templates that allow you to monitor, troubleshoot, and manage Active Directory replication. Here are the key PowerShell commands related to AD replication. 1. Get AD replication failure. This command retrieves information about replication failures for a specified server, site, domain, or forest. It provides details such as the failed replication partner, failure count, first failure time, and failure type. Example: PowerShell. Get a dereplication failure. Target Contoso, DC01, scope server. 2. Get a dereplication partner metadata. This command returns information about the replication configuration and state for a domain controller. It includes details like last successful replication, replication partners, and replication metadata. Example: PowerShell. Get a dereplication partner metadata. Target Contoso, DC01. 3. Get a dereplication site link. This command retrieves information about Active Directory replication site links, which define the replication pathways between sites. It provides details like site link name, cost, and replication frequency. Example: PowerShell. Get a dereplication site link. Filter asterisk. 4. Get a dereplication subnet. This command allows you to retrieve information about Active Directory replication subnets, which define the physical locations of domain controllers. It includes details like subnet name and associated site. Example: PowerShell. Get a dereplication subnet. Filter asterisk. 5. Get a dereplication nuke to date nisavectorable. This command lists the highest update sequence number, USN, for a specified domain controller or Active Directory partition. This can be useful for determining replication progress and identifying potential replication issues. Example: PowerShell. Get a replication nuke to date nisavectorable. Target Contoso, DC01. 6. Sync AD object. This command can be used to immediately replicate a specific Active Directory object to all domain controllers in the forest, regardless of the normal replication interval. Example: PowerShell. Synca do object cn igual John Doe ou igual users dc igual contoso dc igual com. These PowerShell commands provide a powerful and flexible way to monitor, troubleshoot, and manage Active Directory replication, offering more granular control and customization compared to legacy tools like repadmin.exe. By using these commands, administrators can ensure the health and consistency of their Active Directory environment.
So this is a good answer. Let's see if we can ask the same one to ChatGPT. Let me go and get a new chat. So as we can see here, ChatGPT 4.0 has give us the same, actually the same answer as Perplexity, but he added one thing called get AD replication queue operation, retrieves the replication operation queued on a domain controller or replication in process. Okay, so anyway, I think the answer is not that good anyway, but he has added uh, some commands related to the Hyper-V replication. Okay, if you are replicating virtual machines through the Hyper-V, so this is one thing, but this is not what we are seeking. Okay, so let's ask Claude if we or give us the same, or we can ask it to give us another answer. Let's go and ask it to start a new chat. Where is the new chat? And here, if you can give it something like that, and let's see the answer. So here you can see very simple and quick answer. Here we can see that give us a couple of things. Get replication partner metadata. This retrieves replication metadata for domain controllers. Not that good. Get ID replication connection retrieves active direct replication connection for a specific server or all servers. Sync any object. This is common between the three AI tools. Force replication of a specific active directory object. Replicate single object. This command I don't recognize it. Get AD replication site retrieves information about Active Directory replication sites. Site link gets information about the replication site link, the link to the site, or the WAN link, I think. Get a replication subnet retrieves information about Active Directory replication subnets. Test, I think there is no something called test. Okay, this is not an available command. Get replication failure. Okay, this is it. Replication queue. Okay, anyway, so not a completely correct answer, but it's good anyway. So here we can see these are the PowerShell commands that we can use to troubleshoot replication issues. Okay, if we go there, where is this is the PowerShell, and then we can go further with our slides. Here, the replication different or the replication topology differs between or in the Azure environment. Okay, within Azure VNets, you can create subnets, which is the equivalent to sites in the physical world. So, for example, if you need to create a site, okay, so here through Azure, if you need to create a site, you need to create it from the VNets or the virtual networks. If you go again to our AD sites, the site here, this is like the virtual network at Azure. Okay, so you say within Azure VNets, you can create subnets that represent different physical locations or data centers similar to the concept of Active Directory sites. Okay, these subnets can be associated with specific Azure region or area or availability zone to mimic the logical grouping of resources in different geographical locations. The same. So by virtual networks, you can create subnets. This is like a logical presentation of your physical cloud structure. Okay, so this is one thing. As for the replication, when it comes to replicating directory data and services, Azure Active Directory handles that behind the scenes without requiring direct configuration by the user. So you don't intervene with the replication process. He will do that automatically. Azure AD and Microsoft Cloud-based identity and access management service, it automatically handles the replication and synchronization of directory data between various Azure AD points or AD servers, Azure AD servers, to ensure a consistent and up-to-date directory across the Azure cloud infrastructure. So we don't actually do any configuration or don't play with the replication through the Azure. It is done automatically. You only create the virtual networks and create a subnet in these virtual networks or give a subnet to these virtual networks. And this it's like creating a site, okay, in the Active Directory sites. Okay, so this is one thing. As this is the replication topology within Azure, we will not focus on it because we are physically focusing on the physical or on-premise replication. So now this is again one slide, and we can go to this warning. Use of REPL admin, I think it is rep admin, not REPL admin, can impact AD. Due to the power of this utility, it can impact replication of Active Directory. Warning, some of these commands have the potential to break your Active Directory domain services installation and should be only under the expert guide of Microsoft PSS. He will, Mr. Lovandelpour will focus, or when we have some switches concerning this command, it may affect our application or our Active Directory, he will state that and warn us. Okay, so again, we can see building a logical map of your physical network structure. This will be done using the Active Directory sites and services. We have discussed this topology before, or this example before in a previous video, and you can continue working with the site topology. We will see that each site will have at least one subnet. Okay, so site A will have one subnet, maybe 192.168.1.0. This is a subnet. You can have multiple subnets, but at least you should have one subnet, so you can verify your computers within the site. So the IP will verify, or the IP subnet will verify the computers within the site, okay, and differentiate it from other sites with other subnets. Okay, so as you link to a site to another site, you can schedule a replication. So if you link a site to a site, you can control the replication schedule and the link costs. So for example, if site A has a link to site B and site A has a link to site C, and the connection between A and C is fast and the connection between A and B is slow, you can make the replication first to C and then to B. This will be done, or how the Active Directory will know the fast connection from the slow connection through the metric. So for example, if the site link is 11 here from A and C, and the link or the site link from A to B is 10, then he will use 11, then 10. The more cost, okay, based on WAN speed and latency. You decide all traffic should be routed via site A. You set up site links from A, B, and AC. So here we can see there is no direct replication between B and C. So for C to replicate to B, it should first replicate to A and then A replicate to B. So if you need to replicate from C to B directly, you can make a WAN link, and then you can begin a direct replication between site C and site B. We can see the cost of all of the connections is 100. That means that all of connections are fast. For example, if this cost is 110, then this is faster than the other two. Okay, and it will be done first. The most costly one will begin replication first. Later, due to network changes, BR graphic you add site to B and C. Okay, this is correct. And then we can see this is also to create a site link bridge. Anyway, so we can continue working with the environment of Mr. Lovanderpool. Here we can see a couple of things here. Store and forward replication. Here is saying that each domain controller communicates with a subset of domain controllers to transfer replication changes. So if a change is done to DC1, he will replicate the change to a couple of domain controllers, not only one domain controller. So for example, DC1, we can see here he is replicating from DC2 and DC3, and he is replicating to DC2 and DC3. This is for DC1. If we go to DC2, we will see that he is replicating from DC1 and DC3, and replicate to DC1 and DC3. So every domain controller is replicating to and replicating from a bunch or a subset of domain controllers, rather than one domain controller being responsible for communicating with every domain controller. That requires the change. So everyone is replicating to everyone uh, and getting replication from everyone. Okay, so this is the multi-master DC model. Okay, so this is one thing we need to know: store and forward replication. Okay, so this is very, very good example. If we go to the pull based replication, this is very, very simple. If a change is done to DC1 and DC2 need to be verified about this change, uh, we all know that the intra-site replication will be done every 15 seconds. So every 15 seconds, DC2 will communicate with DC1 asking if there is any change done. He will say, okay, there is a change, then he will request the change, and then the replication. Let's see the process. First of all, there is a change. DC1 will ask the DNS server to give it the IP address of DC2. A communication or a purpose authentication will be done between the two, and then DC1 will tell him there is a change happened on me, okay, and then DC2 will request the change, and at the end the replication will happen. This is the pool based replication. Okay, so uh, not every domain controller will push the changes to all domain controllers. No, the one that needs the changes will ask the domain controller. Okay, pool based replication, we have discussed this before. in a previous video. If we go and see this slide, you can see pull replication. Update occurs when a change is made to the directory on one domain controller. The domain control keeps track of the changes that need to be replicated to other domain controllers. This is on the source server. As for the destination, the domain controller that needs to sync its data, the destination, initiates a replication request to ensure that the source domain controller from which it wants to pull the changes. Okay, so we all know every 15 seconds there is a replication or a request for replication. Okay, change it pull. The source domain controller processes the replication request and sends the request changes to the destination domain controller. And at the end, after the change is replicated to the destination domain controller, it updates its own database with the new data and the metadata indicating that the replication was successful. So this is basically the diagram. This is basically the process itself. So as you can see, very, very simple uh, concepts of replication. Okay, if we go and continue Mr. Low van der Poel uh, video, I think we are going fast enough. Okay, so for example, if I go and let me show you all, if you go there and see, let me get further. Okay, one thing here. Again, sorry, let's go and see a couple of things here. Here I'm asking the PowerShell ISE to give me some info about a PowerShell command concerning the replication. So if you need to know any command or a help concerning any command, you can ask the PowerShell ISE help. Okay, and as you can see here, you can get the commands from the PowerShell, okay, by asking it to get command help and give it the command you need. So these are all the commands related to the replication. So as you can see here, this is diagram I have already discussed before. And something here very, very important. In the DNS, okay, I think this is in the forced DNS, okay, maybe for the forced DNS zone or the domain, I don't, okay, this is within the sites, okay, so we can see here that the sites have a part in the DNS. Okay, so the DNS zone, we have domain DNS zone, forest DNS zone, and there is sites actually. We can see there is a part in the DNS to the sites. We can see these are services that are provided by the domain controllers in the site. This is very, very important. So every site will know the services that the domain controllers provides in this site through the DNS. So for example, we need to make sure every domain controller in the site has the LDAP service on it, the Kerberos service on it, the global catalog service on it. We can see it is repeated 3 times because we have 3 domain controllers in Mr. Low van der Poel scenario. So this means that the 3 domain controllers in the site HQ Home Lab have the LDAP service, the Kerberos service, the global catalog service. This is very, very important. So every server in every site can know the services provided by the domain controllers in the other sites. So for example, if the LDAP is not provided by this site, then no replication will happen between sites. If the Kerberos is not available on the domain controllers, then no authentication will happen and then the replication will not happen. If the global catalog is not on the domain controllers, then we will not be able to locate the resources on other sites, or users will not be able to communicate with other resources in other sites. Okay, so this is very, very important to have, or to have all of the services of this provided by the domain controllers in the site to be registered in the DNS, and this will be replicated to the other DNS servers within the forest. Okay, so every domain will have a DNS. It will be replicated to the other the DNSs in the other domains, and in the whole forest we can see all of these. Okay, so this is very, very important. Okay, so if we continue, and we have seen this diagram, and one thing we need to here we can see also, if you go to the Active Directory sites, we can see the coast link. So For example, you have a site called HQLAN to MicroTech LAN. To these two sites, they have a link between them. The cost is 100. If there is another link, okay, cost 110, this will be the fast one. We can see the replication interval 15 minutes because these are two sites. Okay, so this is very good example of inter-site replication. We have microtech site, we have home lab site, they have one link which its cost is 100. We can see from this we can control the replication schedule and we can modify the cost to increase it or decrease it, and this is the replication interval we can see. So this is very good. This is the NTDS setting. This should be replicated to all of the domain controllers. This is very important. Okay, so another concept here is called bridgehead servers. If you need to replicate uh, Active Directory database from one site to another site, so this will be done in certain steps. So for example, we have 3 domain controllers in site A and 3 domain controllers in site B. If we need to replicate the data from site A to site B, then we will choose one server that will take all of the changes that are made in the database of the Active Directory in this site, and he will replicate it to another chosen server in site B. And then this chosen server will replicate it to the other servers within the site. So this is called bridgehead servers. This is very important because uh, not all domain controllers in the site will replicate to all domain controllers in the other sites. We can specify a certain server to be the bridgehead or the bridge between the two sites. We will have one here server to be the first part of the bridge and another server to be the second part of the bridge, and then they will communicate the changes between each other. And then internally, the other site or the other server will replicate the changes to the other servers in the site using the intra-site process. So this is very important. If we continue, we have seen this diagram. Okay, so I think we can continue working. So another thing here, we have seen this store and forward replication. We have seen this slide, and you can see something here. This is links are generated, or this is the topology. It is generated by the KCC automatically. So if any change is done to the topology, for example, if you remove a server or add a server, the topology will be changed. Okay, and the one responsible for changing the topology, and it is saved in the NTDS, is the KCC. So it is very important for the KCC to be available on all servers or domain controllers, so the topology will be up to date and we can know which server is down and which server is not down. So for example, if we ask ChatGPT for a certain question or a simple question, let me show you here. For example, here when I ask it uh, to explain or when should I use the KCC. So here, for example, when should I use the command rep admin -kcc? Uh, okay, but I think let me do not pass it quickly. Let me stop, or because this I think we can discuss it later. So let's first continue with the slide, and I will stop at a certain thing here. So we have seen this slide request. So I will stop here at KCC. Okay, we will stop at minute 13. We will discuss the KCC and when to use the KCC and what are the scenarios we can rebuild or use the KCC to rebuild the topology of our network. So I will stop at minute 13:07. Hope this video informative for you all, and thank you all for viewing. Thank you so much.